Welcome back to Maths with Mrs. J. We've been talking about derivatives of the inverse trig functions. In our previous video, we learnt these basic rules. That the derivative with respect to x of inverse sine of x is 1 over square root 1 minus x squared. Very similar for inverse cos, it's negative 1 over that. And for the derivative of inverse tan of x, the derivative is 1 over 1 plus x squared. I'm just going to do some examples using those rules and using our other basic differentiation rules such as the product rule and the chain rule. Let's have a look at our first example here. So we have f of x is x tan inverse of x. This is a product, isn't it? So our derivative using our product rule and using my very unmathematical way of remembering it is your first thing times the derivative of the second thing. Derivative of inverse tan is 1 over 1 plus x squared. And then we get plus the second thing times derivative of the first thing. Derivative of x is just x. So we end up with, of course, x over 1 plus x squared plus inverse tan of x. So that was using our product rule. For question 2, we're going to need to use our chain rule. We have a function of a function. Our inner function there is a linear function, ax plus b. The derivative of a linear function is just going to be a constant. In this case, it will be a. What we're going to get when we use our rule, dy dx, is obviously going to be 1 over square root 1 minus our ax plus b squared. And in fact, I would be inclined just to change that 1 to an a because you're multiplying through by a. We know that we're doing that because of our chain rule. Okay, this one here, again, chain rule is going to be useful. Let's see how it actually plays out when we simplify the expression a little bit though. So g dash x is obviously going to be your 1/5, which is the derivative of x over 5, over square root 1 minus x on 5 squared. Now, when we fiddle around with this a little bit, what we're going to end up with is a 5th in our numerator. In our denominator, we're going to put everything over 25. So we're going to have 25 minus x squared over 25. Take the square root of 25 and you get 5. So the 5's actually cancel and you're left with 1 over square root 25 minus x squared for that one. This one here, again, we should write chain rule. Again, we're going to write that we're using our chain rule. Derivative in this case of the inner function is 5. So h dash x is going to be, in this case, -1 over your square root 1 minus 5x all squared times your 5. If we just fiddle around with this a bit, we get -5 over square root 1 minus 25x squared. We don't have fractions there that we need to cancel or anything like that. Again, we have a chain rule situation for question 5. Our inner function is the square root of x, which is x to the half. So just bear that in mind. Square root of x is x to the half. So when we do our chain rule here, well, our normal process for inverse tan of x is 1 over 1 plus x squared. So we're going to get 1 over 1 plus, in essence, root x squared, if you really need to show that level of working. But then we're going to multiply by the derivative of x to the half, which is a half x to the negative a half. So just tidying that up a bit, this bit here will just become 1 over 1 plus x. This will be a 2 in the denominator, and this will be a square root x in the denominator. So I'd be inclined to write this as 1 over 2 root x, 1 plus x, and leave it like that. And there you have it. So that's again using your chain rule. Basically what I'd like you to be able to do is whenever you learn new functions, learn their derivatives and add them to your repertoire of functions that you are able to differentiate, throw into the mix products, quotients, chain rules, any sort of mixture like that, and you should be able to do it as long as you know these basic rules for each new function that you get.